Number 14. Use Gaussian elimination to show the set of equations has a unique solution when a is not 2.5. What happens when it's 2.5? And then get the answer when a is 3. That's for 7 marks. Oh well. Right, I've already set it out here. Now, since it's just tedious, I'll just speed through it. So it's just a case of you copy it out again, copy around the first line, that's going to change. I want that to start with 0, so take away the top row. I want that to start with 0, so take away 2 lots of the top row. And then that part will be a, take away 2, so it's a minus 2, and that's going to be 0. Then finally I need to get that one down to 0, so just copy those 2 rows down again. So this will need to be that, 2 of them take away the row above. So that'll give the 0 the 0, that'll be 2a minus 4 minus 1 is 2a minus 5. And that'll come to 1. Now, 2a minus 5 can't be 0 because you'd have 0 times something times z equals 1, so that would be inconsistent. So you would say the system would be inconsistent for 2a minus 5 equals 0. That would be a equal to 5.2 or 2.5. Or conversely, that means there would be a unique solution for a not equal to 2.5. Now, the question actually then says explain what happens when a is 2.5, and I've just done that the other way around, so it's just a case of writing that first bit. At 2.5, the system is inconsistent. Obtain the solution when a is 3. Right, if a is 3, when a is 3, right, well if a is 3, that means you've got, I'll just put it all down, 2 times 3 minus 5, z equals 1. Well, that's just 1. So z equals 1. And if z equals 1, go back up a stage. 2y plus the z is negative 1. So 2y is negative 2. So y is negative 1. Go back up a stage. X minus negative 1 plus 1 equals 1. So that's x plus 2 equals 1. So x equals negative 1. Or if you like, negative 1, 1 for the solution set. Right, in the next bit, you're given 2 matrices, you've got to get the product. So that's just a case of multiplying them. Right, so just speeding up this bit then. So copy out matrix A, and then multiply it by copy matrix B. So multiply row times columns. That's 5 and nothing, negative 6. That's 1 and nothing, negative 2. And negative 3 and nothing, and 4. So that'll add up to negative 1, and 1. Now this last part gives you this matrix C, another 3 by 3, and it says what's the connection between them? Well, what do you think? When you meant to multiply them together to see if they come to 1, you could do that if you liked, because you suspect it's something to do with the inverse. But if you look back at the beginning, C was that original system of equations. When you set out that system of equations in matrix form, what you were really doing was you were saying C, taking these coefficients, you were really saying this, 1, negative 1, 1, 1, 1, 2, 2, 1, negative 3 times x, y, z was to give 1, 0, 2. You were solving that system using Gaussian elimination. And that x, y, z was actually this. Which means that what you could state for this part would be this. You could say, well, C times negative 1, 1 gave the answer 1, 0, 2, because that was the solution set multiplied by C to give this. And A times, you just did it, 1, 0, 2 gives the answer negative 1, 1, which must mean they're the inverses of each other, which means that A must equal the inverse of C, or vice versa, or C equals the inverse of A. Whoops, a daisy. Number 15, calculate the area of this petal shape, hence get the area of all 4 bits. Right, so it's just the area between 2 curves. So what were they again? You had y equals x squared, and you had y squared equals 8x. Right, well, y equals x squared, that's the standard parabola, so that'll be the lower curve is y equals x squared. The one that curves the opposite way is y squared equals 8x, like y equals the square root. Right, I'll need to find the points of intersection to do the integration, and then 4 times it for all 4 bits. So first of all, intersection. So I'll substitute 1 and 2. So that means instead of y, I write x squared. So x squared squared equals 8x. So 8 to the power 4 minus the 8x is 0. All I can do is take out an x times x cubed minus 8 equals 0, which means either x equals 0 or x equals the cube root of 8, or x equals 8, x cubed is the cube root of 8, which is 2. So it's going from 0 to 2. So the area is going to be, because there's 4 of them, 4 times from 0 to 2 of the top. Now, the top will need to have written in terms of y though, that's y squared. So it'll have to be the square root, so I'll have to take that, I'll have to do y equals the square root of 8x. So that's the square root of 8, that's 4 2's, that's 2 root 2 root x. 2 root 2 root x, but I need it in index form anyway. So the top one is 2 root, did it again, 2 root 2 x to the half minus the bottom one, which is x squared. So it's just a case of evaluate that. 4 times, so it'll be up to 3 upon 2, and then divide by 3 upon 2, which is the same as times 2 upon 3, times 2 upon 3, that's 4/3 root 2, minus up to 3, divide by 3, work it out at 0, easy, they'll disappear, work it out at 2. So we're almost there, we're just going to work it out at 2. So that's 4 upon 3 root 2 times 2 to the power 3 upon 2 minus 1/3 of 2 to the power 3. I'll just put minus 0 for that part there. Well, of course that's 4 times the whole lot, including that 0. Working out that part then, well, we're going to take those thirds out. 4/3 of 3 upon 2, another half, that makes 4 upon 2, that's 2 to the power 2, that's 4, so 4 4s, that makes 16, and that's 8, and I've got 3 already, so minus 8, so that's going to be 8 times that, so you've got 32 upon 3 units squared for the answer. Right, that was the first bit. What's the area of that design? Now the second bit says the counter is formed by rotating this same part here, this same area, around the y-axis. So form this sort of little vase shape with a cross section like that, aerofoil, like that, petal shape. Right, that means I need things in terms of y. So you knew that that was at 2, that means that that coordinate there must be, you must have y equals 2 squared. So it's going to go from 0 to 4, that's the first bit. And the second thing is this, to find the volume between them. If I just rotate that curve on its own, I would get a solid paraboloid, it would be called. I'd want to take away the volume of this fluted shape that would be produced, like a trumpet, if that was rotated. So it's the subtraction of 2 volumes. So I could put down my volume formula anyway. The volume formula would be this. It's going to be pi times r squared h, if you like, or dh, because I'm adding them all up. But I'm adding them up this way, so I'm going to want pi x squared dy for each of them. So I'm going to do a subtraction, but instead of doing 2 separate subtractions, you know, pi and then that formula from 0 to 4, and then subtract pi and then that formula, I'll just do it in the one. So it's going to be this, it's going to be pi times from 0 to 4 of, now, the outer one, which is x equals, which would be, I want x squared, and x squared is y, so that's nice and neat, so it's y minus, because I need x squared, and that was x squared. Here, I'll just rearrange it, y squared is 8x, so x is going to be an 1/8 of y squared, but I want x squared, so the second formula would have a 64th of y to the 4, 1 over 64 y to the 4, and all dy, because everything's in terms of y. That would be it. Outer, meaning the whole larger volume minus the missing inner volume, that's this part. 2 separate integrals, but you can just do them together. And now it's just a case of integrating it. So that's going to be 1/2 of y squared, that's going to go up to 5, and then divide by 5. Well, it's going to be a bit of a pest dividing by 5. So that's what, 2320 then for that part. That's a bit of a nuisance, right? And then work it out at 4 and 0. Well, the 0 doesn't matter. So times, I could take a half out. I'll take the half out just now. So times, and that's going to be 4 squared minus, I took out half, so that means what I'm left with there is just 160 times 4 to the power 5. Suppose you could just use a calculator for that. Well, I'll take out 4 squared, so I'll take out 16, so 16 pi upon 8 times, that just leaves 1, and that leaves 4 to the power 3, but 16 is 4 to the 2, so that would cancel out one of them, just leaving a 4, that leaves a 10 underneath, so I've got, Whoops, recording cut out there, so that would have been 16 pi upon 2, which is 8 pi, 6 upon 10, which is 3/5, multiplying them 24 pi upon 5 units cubed for the volume. So, question 16, what does it say? Use the Moivres to express z cubed. Well, here it is, expressed in polar form to begin with anyway, to express z cubed in polar form. That means cube that side, cube the r, and cube the bracket. There we. So that'll be r cubed, and then de Moivre's would just be, so you multiply the angle by 3. So that's the first part. Second bit. Hence obtain this. Cos 2 pi upon 3 plus I sine 2 pi upon 3 cubed in the form of, in rectangular form, Cartesian form. Yeah, well, that was the first bit. Well, that would be, that's why I keep saying this hence, that just means doing the same as this, multiplying the angle by 3. So that's simply going to be cos of, and I have to show this then, 3 times 2 pi upon 3 plus I sine 3 times 2 pi upon 3, which will just be cos of, 3's cancel, 2 pi, plus I sine of 2 pi. And you know what that is, if you just think of that in a Argand diagram, 2 pi means you're all the way around, so you're here, at the point 1. But I have to do it from this then. Well, cos of 2 pi is 1, sine of 2 pi is 0, so it's 1 plus 0. But it says confusingly in the form a plus ib. Well, it is in the form of a plus ib. That's in the form of a plus ib, where a equals 1 and b equals 0, if you will. But effectively, the answer is just 1 though. Right, next part. Hence or otherwise. Now, the hence bit's not so good from here. I don't know if that was meant to be a help, but you'd be better off just starting from scratch. But anyway, hence or otherwise. So, clear it. So, hence or otherwise. Well, the hence must mean somehow using the part before. But there's a couple of otherwises that I'll do afterwards. Well, if z cubed equals 8, we already had from before that cos 2 pi upon 3 plus I sine 2 pi upon 3 cubed equals 1. Which means that to get 8, we would just do 8 times that. So that must mean that z cubed is 8 times cos 2 pi upon 3 plus I sine 2 pi upon 3 cubed. Which means effectively you've got the roots in there. I'll just change that to a 2 cubed, just to make that complete. But also, significantly, so that means for the roots, you'd have this, which means z would be, taking the cube root of all the sides, it would be 2, cube root of that. Cube root of that is just that expression. But you've got the cos of 2 pi upon 3. Now, when it's cubed, it's to come back to this. If you were to add on any number you like of 2 pi upon 3's, then when you cube it, this will get multiplied by 3 to produce what you want. This will get multiplied by 3 just to produce rotations of 2 pi. Plus I sine 2 pi upon 3, which happens to be the angle. It's just more confusing, I suppose, because it's on the axis, because the actual number is at 0 in the first place. If it was somebody else, it'd be clearer. That's the part that would take you to that position, and this part simply produces more rotations that take you back to that position, plus n of 2 pi upon 3. Because when you do power 3 of this, it'll just go back to that, because all you're doing is adding on some 2 pi's. 2 pi, 4 pi, 6 pi, and so on. So that means z could be that, where n could be, but it'll only be 3 times you could do that, because then you start repeating yourself. So z would be that. So I've got my answer would be this. To n equals 0, my first answer, my first root would be this. 2 times the cos of, if n is 0, it's just going to be 2 pi upon 3. That's the one you had already. Plus I sine 2 pi upon 3. Next answer, 2 times cos of, this time make it 1. So that'll be 2 and 2 is 4 pi upon 3. 4 pi upon 3 is a different angle from 2 pi upon 3. But multiply it by 3 and it just goes back to the original. Plus 4 pi upon 3. Z3. Now we know that was taking n equals to 0. N equals 1 now, take n equals to 2. 2 times cos of, now if n is 2, that'll be 4, that'll make 6 lots you'll be adding on. Plus I sine 6 pi upon 3. And there's the 3 roots. But I want it in Cartesian form just as well, because I'd have to tidy them up. That'd have to become 0, and that'd have to be, since it's going beyond the halfway mark, the angle that you use as the argument there would have to be negative 2 pi upon 3. Still, I want it in the Cartesian form. So the Cartesian form would be this. It'd be 2 times cos 2 pi upon 3. Just think of that. 2 pi upon 3 puts you here. So the cosine, that's going to be negative, and of 60. So that's going to be negative a half. Plus I times the sine would be positive of 60, that'll be root 3 upon 2. So that gives you then 2 times that would be negative 1 plus root 3i is 1 root. Z2, that's just going to be the same. Round to here, it's still the 60 this time, they're both negative. So the cosine's negative and the sine's negative. So that's the negative 1 minus the 2's cancel, root 3i. And the third one, the third root's going to be 2 times, this time it's just cos 2 pi, that's 0. So the cos of 0 is 1, and the cos of sine is 0. So that's just going to be 2. So there's the 3 roots. Doing what I reckon is the hence way. So, hence or otherwise. Now, one of the otherwise ways would be this, just starting from scratch, as if there was no preamble to it, as if it just said, find all the roots of this equation here. So you'd have to first of all think, right, where's 8? 8's here. So in polar form, what would 8 be? So you've got z cubed is 8 at an angle of 0. So it's 8 cos 0 plus I sine 0. Which means to get z, I'm going to do the cube root of them both. So it'll be 8 to the power of third and cos of 0 plus I sine 0 to the power of third. And then you would say this part, well, 0, well that could be 0, or it could be 0 plus 2 pi, or 0 plus 4 pi, or 6 pi, or anything you like. So 0 plus n lots of 2 pi plus I sine 0 plus n lots of 2 pi to the power of third. I'll just take that inside with the Moivre, divided by 3. Now they're all not going to produce unique results, only so many of them will. You only need the first 3 of them, 0, 1, 2 and 3. 0, 1 and 2. So that you're going to have, well, 8 to the third is 2. So the answers would be, for my first one, I'll take n equal to 0. So I've got 2 times, if n is 0, it's just going to be cos 0 plus I sine 0. That's with n equals 0. Z2, this time we're going to take it with n equals to 1. So it's going to be cos, if n is 1, it'll be 2 pi upon 3 plus I sine 2 pi upon 3. I think it's much easier just to have done this. And when n is 2, I'm going to have 2 times cos of 4 lots now. So 4 pi upon 3, nothing plus 4 pi upon 3. That's when n is 2. If you tried it for the third one, you'd have 6 pi divided by 3. It just takes you back to this. They would just keep cycling through these 3 altogether. That's why you'll need to take the first 3. If it had been divided by 4, you'd have had 4 values, and then they would cycle through the 4. And then, as before, if you wanted them in Cartesian form, well, same answers, isn't it? Cos of 0 is 1, and that's nothing, so that's 2. And then there's the 2 pi, which is negative, and the 4 pi, which is negative for both of them. Right, now, the third way. Right, so now the third way, because it did say hence or otherwise. So the otherwise would be this, just to do it purely algebraically, because some cases it wouldn't be so easy, but here in this case it's especially easy, because I've got this, I've got z cubed minus a equals 0, which is the difference of 2 cubes. Z cubed minus 2 cubed. And that factorises readily to z minus 2 times z squared plus 2z plus the square of 2, 4. There's one answer already, it's already equal to 0. That's irreducible, 2 squared, that's 4, take away 16, that's negative 12. So the roots are going to be either z equals 2 straight away, or I'll need to use the formula there. Z equals negative 2, all over 2 times 1 is 2, plus or minus the square root, we already had that, so it's going to be negative 12. So you've got z1 is going to be 2, or you're going to have z equals, no that's that, square root of 12, that's 4 times 3, that's 2 root 3. square root of 12. That's 2 root 3. So that means I've got negative 2 over 2. That's negative 1. I'll just do the minus first, and I'll do the plus first of all. Plus, and then I've got 2 root 3i divided by 2 is root 3i, and the other one's going to be z equals negative 1 minus, same again, root 3i. And then you get the three answers straight away. Oh, there it is. In this case it was quite easy just to do it straight away by factorisation. So, the last part, denoting the roots by z, 1, 2 and 3, did that anyway, and there they're up there again. State the value, there's only one mark, state the value, put it down here, state the value of z1 plus z2 plus z3, well it always comes to 0. You know that anyway, here look, you've got 2, take away 1, the real part comes to 0, imaginary part plus root 3 minus root 3 all comes to 0. B, obtain the value of z1 to the 6 plus z to the 6 plus z3 to the 6. Well, these are the roots. Those were the roots of the equation z cubed equals 8, which means z cubed equals 8. So each of these cubed equals 8. So if you've got z1 to the power 6, that's z cubed squared. So there, you've got 8 squared, 8 squared, 8 squared. So that's just going to be 3 lots of 64, 1292. The answer to that part. Oh, there's the answer to that part.